Hello and welcome. In this video we will discuss the interpretation of graphs for issues with second-degree functions. Such a function gives us more information than we think. Last week my good friend and wine grower Valère called me to tell me that he has bought a new wine cask. He asked me whether I could help him with some calculations to make a better profit. So I asked him how I could do that. He gave me 3 problems, so let's have a look at the first problem. Valère read in Le Vin Quotidien that the revenue of thousands of kilograms of grapes depends on the amount of fertilizer used per hectare in metric tons. The relationship can be described with the function f of x equals 1 plus 1.08x minus 0.3x squared. He asked me, how much fertilizer per hectare should we use to maximize the revenue? Let's have a look at the graph. So we draw the graph and we put the function over here in standard form, where the term with x squared comes first. At the x-axis, we see the amount of fertilizer used, the amount of manure used, and at the y-axis, we see the revenue factor. The revenue factor is a number by which our revenue is multiplied. So, we see the relationship between the amount of fertilizer used and the revenue factor. Let's have a look at a first special point. This point where the parabola cuts the y-axis is special because we have an x value of 0. So there is no fertilizer used, but we have a revenue factor of 1. That's a very logical thing, because even if you don't use fertilizer, we can grow grapes, but we can do better with this field. If we look further into the graph, we see that the money back is growing by adding some fertilizer. The revenue factor starts to increase because the graph is increasing. The manure improves the quality of the field, which increases the revenue. At a certain point, however, this point, we see that the revenue factor starts to decrease. The money back is shrinking over here. This means that the cost price of the used amount of manure is not viable. Valère spends too much money on his fertilizer. So, there is a point on the graph which the revenue factor is as big as it can get. Over here we have the biggest money back ever. It's huge. So, at this point, we call it the vertex of the parabola, we have an ideal situation. We have the information about the amount of manure that we can use to have the biggest revenue. If we look at the x-coordinate of the vertex, we see that 1.8 tons per hectare is the ideal amount of fertilizer to use. With this amount of fertilizer, we have a revenue factor of almost 2, which means we can almost double our revenue. If we go further on the graph and fall below a revenue factor of 1, we see that we have a very small money back. Over here, Valère simply uses too much manure. It's even a smaller money back than over here, and that can't be the intention. If we go deeper on the graph and exceed the x-axis, you can see that the amount of revenue is even below 0. The ideal situation is still the vertex with 1.8 tons per hectare. So, Valère, use 1.8 tons per hectare and you have the greatest revenue. Apart from the amount of fertilizers, Valère also wants to know how long he needs to store his wine bottles in order to have a maximized profit. Valère has produced 300 bottles of wine. If he were to sell these right now, he would earn €7 per bottle. If he stores them, the price per bottle goes up by €0.5 each year. Every year, he drinks 10 bottles himself. When should he sell his wine in order to maximize his profit? We are now looking for a function that reflects the profit according to the number of years the bottles are kept. The longer the bottles are kept, the more profit per bottle. But we can't forget that Valère drinks 10 of them every year. To calculate the profit of the bottles, we have to multiply the number of bottles by the price of a bottle. We take X as the number of years the bottles are kept. So, the number of bottles is equal to the stock of 300 minus the bottles drunk. This is represented here in the color red. The bottles he drinks we can describe as 10 times X, because he drinks 10 bottles every year. The profit per bottle is represented in blue. It rises by €0.5 each year and it starts at €7 per bottle if the bottles are sold right now. This is our function. You could work this out with the distributive property and put the function in its standard form, but this is not needed to answer the question. During the development we can make calculation errors, and actually we can extract all the information from the graph. Let's draw the graph. We see that this is a concave parabola with a maximum, so we have a certain point where we have a maximum gain, and that is exactly what we're looking for. We are now at this point, because 0 years have been passed. Everything to the left of the y-axis is not important in this case, because we are not able to go back in time. Not yet. So, Valère hasn't drunk any bottles, and his bottles have not yet increased in value. We fill in 0 years in our function and see our total stock of 300 bottles, and we multiply this by 7, the profit per bottle after 0 years. We have a total profit of €2,100. We see that the total profit increases when we go to the vertex. And when we are over the vertex, the profit decreases again, because Valère drank too many bottles himself. From the intersection with the x-axis and the parabola, we can see that after 30 years, we don't have any profit anymore, because Valère drank all his bottles himself. We now look at the vertex. At the vertex, we can see that after 8 years, we can get the largest amount of profit from the bottles, namely €2,420. We see in the bar chart that before the vertex, the total profit is slower because the wine is still too young, and after the vertex, Valère drank too many bottles himself, so the profit drops again. So, we can tell to Valère that it's best to sell his bottles after 8 years. The last question of Valère is about how best to plant his grapes. In order to produce his different wines, Valère wants to grow 3 different types of grapes on a square-shaped field with sides of length 200 meters. And he wants it according to this pattern, because it looks nice. The grapes all have a unique price and shape in terms of planting. Planting the blue Gamay grapes in the square zones costs €20 per square meter. The green Chardonnay grapes cost €50 per square meter, and the purple Pinot Noir costs €40 per square meter. How long should the length of X be so the total cost is minimal, and what is the minimum cost for Valère? Contrary to the previous 2 exercises, we will now complete the function equation. We need a function that displays the total cost of the field as a function of the length x. We got the price per square meter of each zone. If we want to know the total cost per zone, we need to determine the areas as a function of x. We first determine the area of the Chardonnay grapes. These have a rectangular shape and occur 4 times. The area of the rectangle is length times width. On the drawing we can see clearly that the width is represented by x. The length needs to be expressed as a function of x. If we look at the middle strip, we have twice the length of the rectangle and once x, which should be equal to 200 meters. So the length indicated by the red arrow can be written as 200 minus x divided by 2, The total area is now written as 4 times length x times 200 minus x divided by 2. And we can write this more easily. So the area is now equal to 2 times x times 200 minus x. The blue pieces are squared, so the area is equal to side squared. We know the length of the side from the previous calculations, so we can fill this in. The 4 that is in the front of the square can be dropped because we have in the denominator 2 squared. We have a total area of 200 minus x squared. By logical reasoning, we know the purple piece is also a square, so the area is equal to x squared. To determine the total cost, we can multiply the area in squares by the price per square meter. We obtain for the green piece 30 times 200 minus x, for the blue area 20 times 200 x squared, and for the purple piece 40 times x squared. Our function is the sum of these terms and describes the total cost of the field as a function of the length x. Again, we will not elaborate on the function algebraically, because we can derive all information from the graph. If we draw the function, we get this convex parabola. With this kind of parabola we have a minimum, and that is logical because we need a minimum for the lowest possible cost. Since we work with big numbers, we have to adjust the scale of both axes to get a clearer view. Looking at the minimum, we see that the length of x must equal 33.33 meters to have the lowest possible cost price of the field. The lowest possible cost price is 76,666 euros, which can be read from the y-coordinate of the vertex. We still have 2 special points in the graph that we can look at. A first point, the intersection with the y-axis. The length of x equals 0, which means that the entire field is occupied by the Gamay grapes. So we can derive the cost price from those 20 euros times 200 squared, and that is 800,000 euros. If x equals 200 meters over here, the entire field is occupied by the most expensive grapes. This gives a cost of 1.6 million euros. This is double the amount of the field full of Gamay. This makes sense because the purchase price is also double. So Valère chose 33.33 meters for the x, and you have a minimal cost for your beloved wine field. By solving the 3 math problems, Valère can save a lot of money. We don't always have to do the difficult calculations. We just saw that you can get all the information out of the graphical interpretation. Okay, I will call my good friend Valère now. Thanks and see you soon.